Check the question number 12. Question number 12 is several electric bulbs designed to be used on a 220 volt electric supply line are rated 10 watts. How many lamps can be connected in parallel with each other across the two wires of 220 volt line if the maximum allowable current is 5 ampere? In this question it is given here the potential difference of the electric supply line, it is 220 volts power of one bulb is 10 watts, and here we have to find how many lamps are connected in parallel. Okay, and the current through the whole circuit is 5 amperes. So first we will consider, let n be the number of lamps connected in parallel. Okay, now the power of one bulb is 10 watts, so what will be the power of n lamps? Okay, it is power of one lamp is 10 watts, so power of n lamps you can consider as the total power. So simply you will multiply n by 10. So what you will get here, 10n watts. Clear? What is the electric current? Electric current is how much? 5 amperes. So what is the formula of power? It is V into I. What is power of n lamps? It is 10n. What is V? 220 into electric current is 5. So it is divided by 10. What you will get? 22 into 5 is 110 lamps. Clear? Now next question number 13. A hot plate of an electric oven connected to a 220 volt line has two resistance coils A and B, each of 24 ohm resistance, which may be used separately, in series or in parallel. What are the current in the three cases? Now here we have got the three oven plates which are resistance coils, each having same resistance value 24 ohms. Now they are asking to find the current in the three conditions. The first condition is if we will connect the two plates or two coils separately, then what will be the current in the two resistance coils separately. Okay, as we know that दोनों resistance coils सेम रेजिस्टेंस वैल्यू की है. क्लियर? तो दोनों में करंट सेम फ्लो करेगा, जितना कि R1 में फ्लो करेगा उतना ही R2 में भी फ्लो करेगा. So what is the potential difference given here? $220 volts. Clear? The first condition is when the two resistance coils are separate. So case number 1 is when R1 and R2 are used separately. So what is the potential difference is given here? 220 volts. Now first you will find the current through the resistance R1. So we can apply the formula, that is I is equal to V upon R. What is the potential difference? It is 220 volts and resistance R, it is 24. क्योंकि दोनों में same है, so simply you can write R. So dividing by 24, what you will get? 9.17 ampere. Clear? So we can write the statement over here. Since the two coils are same, coils are of same resistance value, so the current will also be same through R1 and R2. Okay, that means 9.17 amperes. Clear? Now second part is when the two coils, they are connected in series. Okay, one thing you have to remember here. Potential difference, that is same 220 volts. But what is changing here? The combination of R1 and R2, that is changing. So accordingly you will find out the equivalent resistance. Now since R1 and R2, they are in the series combination. So for the series combination, the equivalent resistance is given by the formula R1 plus R2. R1 is 24. R2 is also 24. What you will get here? 48 ohms. Therefore, the current in the series combination is given by the formula V upon R. What is the value of V? It is 220. And what is R? 48. Dividing by 2, or you can divide it by 4. 4 12s are 4 5s are 20 and 4 5s are 20. Dividing 55 by 12, what you will get? 4.58 amperes. So this is the current in the series combination. Clear? Now for the third combination. Okay, now in the third case, we have to connect the two resistors R1 and R2 in the parallel combination, and then for this parallel combination you have to find the total current. Okay, so for the parallel combination, what is the formula? 1 upon R is equal to 1 upon R1 plus 1 upon R2. R1 is 24 plus 1 upon R2 is also 24. So you will get LCM as 24 in numerator, 1 plus 1, which is 2 upon 24, dividing by 2, you will get 1 upon 12, or we can reciprocal both the sides, you will get 12 upon 1, that is R is equal to 12 ohms. Clear? Now we can find the current. What is the formula of electric current I in terms of V and R? It is V upon R. V is 220 volts and resistance is 12. dividing by 4, 3s are 4, 5s are 4, 5s are dividing 55 by 3, you will get 18.33 amperes. Okay, so this is how you have to calculate the electric current for the three different combinations according to the series and parallel combination. First you will find the total resistance and then you will apply the formula of current, that is V upon R. Clear? Okay, now next question number 14. Compare the power used in the 2 ohm resistor in each of the following circuits. Number 1 is a 6 volt battery in series with 1 ohm and 2 ohm resistors, and in second part a 4 volt battery in parallel with 12 ohm and 2 ohm resistors. Now here you have to calculate the power used in the 2 ohm resistors. As you can check in the first part, there are two resistors. So as you can see here, in the first part we are having the potential difference 6 volts. R1 is 1 ohm and R2 is 2 ohms. R1 and R2, they are connected in the series combination. Calculate the power through the resistor 2 ohms in the first part, okay. Then in the second part also you have to calculate the power through the 2 ohm resistors, and then you will compare the powers in these two parts, which is through the 2 ohm resistor. Now the condition is, in the first part the resistors they are in series, and in the second part the resistors they are in parallel combination. So for calculating the power, first find the electric current for the series combination. As we know that in the series combination what remains same? The current. Okay. So first you will find the total current through the circuit, and the current will be same through the R2 also, and then you can apply the formula of power, that is V into I. Clear? So for that you have to do is, so for that you have to find out the total resistance in the series combination, that is R is equal to R1 plus R2, which is 1 plus 2, that is equal to 3 ohms. Now find the electric current, that is V upon R. What is V? It is 6 and total resistance is 3. So what you will get? 2 amperes. Now this 2 amperes current will flow through the R2 also. So we can write here, since current remains same through the resistors in series, okay, therefore what is the formula of power? It is in terms of I and R, it is I square R. What is the value of I? It is 2 square into resistance R is 3. So square of 2 is 4 into 3, that is 12 watts. Clear? So this I square R. So in place of 5 we can write 2 square into what is R? It is 2. So square of 2 is 4 into 2, that is 8 watts. Clear? So you have to first check the current flowing through the 2 ohm resistors. Okay. Now as you know that in parallel combination potential difference remains same and resistance R2 की value कितनी है? 2 ohms. So we can apply the Ohm's law, that is I is equal to V upon R. So current through R2 is given by the formula of electric current, that is I is equal to V upon R. What is V? It is 4, and what is our resistance? We are checking through the R2, so you will put the value of R2, which is 2. So dividing by 4, what you will get? 2 amperes. Okay. And now since we have to calculate the power through the 2 ohm resistor, so what is the formula of power? It is V into I. What is the voltage? As we know that voltage remains same through all resistors, so it is 4 volts. And what is the current through the 2 ohm resistor? It is 2 amperes. So 4 2s are 8 watts. So you can check in both the cases, first and second part. The power consumed through the 2 ohm resistor is 8 watts. So it is same. Okay. Okay, now next question number 15. Two lamps, one rated 100 watt at 220 volts and the other 60 watt at 220 volts are connected in parallel to electric main supply. What current is drawn from the line if the supply voltage is 220 volt? As you can check here, we have got the two lamps. Power is 100 watts and the voltage 220 volts for the lamp number 1. For the lamp number 2, power is 60 watts and the voltage is 220 volt. So you have to calculate the total current through the whole circuit. So what you have to do is, we know that in parallel combination, the current is divided into the parts according to the number of resistors connected. Okay. So here we are having the two lamps. So what you have to do is, first you will find the current through the lamp 1, then you will find the current through the lamp number 2, and then you will find the sum of these individual currents, and then you will get the total current of the whole circuit. Okay. So what is the formula of power? It is V into I, or we can write I is equal to P upon V. What is P? 100 and voltage is 220. 0 0 cancel. 2 11s are 2 5s are. Dividing 5 by 11, you will get 0.454 amperes. Clear? Then for the second lamp, you have to find the electric current. So by the same formula, we can apply P upon V, which is 60 watts divided by 220. 0 0 cancel. 2 11s are 2 3s are. So it is 3 upon 11. So on dividing, you will get 0.278 amperes. Therefore, the total current I is equal to, you can consider this as I1 and this is I2. So I1 and I2, you will get 0.454 plus 0.278. So on adding, what you will get here? 0.732 amperes. Is that clear? Next question number 16. Which uses more energy, a 250 watt TV set in 1 hour or a 1200 watt toaster in 10 minutes? Now here we are having the two devices. The first is TV set. The power of TV set is 250 watts and the time for which it is used is 1 hour. Clear? And what you have to calculate is energy consumed, that is E. As I have told you earlier, for calculating the electrical energy consumed, the power should be in kilowatt and time should be in hours. So here the power is given in watts, so we have to divide it by 1000 for converting it to kilowatts, or directly you can place the decimal after 3 digits from right to the left, that is 1 2 3 kilowatts. Clear? Time is given already in hours. So what is the formula of energy consumed? It is power into time. Power is 0.25 and time is 1. So it is 0.25 kilowatt hours. Clear? Now check the second device. It is toaster. For a toaster, what is the power? It is 1200 watts. So you will convert into kilowatts. So you will place the decimal after 3 digits from right to left. 1, 2, 3. So it is 1.2 kilowatts. Time is given 10 minutes. So here we will convert time into hours. For that we have to divide it by 60. 0, 0 cancel. So it is 1 upon 6 hours. So calculate the energy. Energy is the product of power and time. Power is 1.2 kilowatts and time is 1 upon 6 hours. Dividing by 6, you will get 0.2. So it is 0.2 kilowatt hours. Okay, so you can check it here. Which device is consuming more energy? A TV set. So we can write here TV set consumes more energy. Question number 17 is an electric heater of resistance 8 ohms draws 15 ampere from the service mains 2 hours. Calculate the rate at which heat is developed in the heater. Now in this question the resistance is given 8 ohms, electric current drawn as 15 amperes and the time is given 2 hours. Okay, now just check the question, the last line. Calculate the rate at which heat is developed in the heater. Heat क्या है? Energy है और rate का मतलब speed, means the speed at which the energy is produced or developed in the heater. That means we have to calculate the power. Okay, now here we are having R and I, and what is the formula of power in terms of I and R? It is I square R. So it is 15 square into 8. Square root of 15 is 225 into 8. That is 1800 watts or 1.8 kilowatts. Clear? So last question number 18, that is theoretical portion, okay, and that we have discussed already also. So I will send you the notes for the question number 18 and some of the important topics notes also on your Tano app. You can check it over there. If you have any queries, you can send me personally also on my WhatsApp number or on the Tano app also. Okay, thank you.